So, as we see here, we have a signal coming from the signal generator and it's being measured with the oscilloscope here on the monitor. So we have an alternating voltage, okay, that varies with time. So we can see that time here is on the x-axis and voltage is on the y-axis. So the signal that we're inputting into the oscilloscope is a 4 volt peak to peak AC signal, AC sine wave, and it's being input at 2 Hz. So the signal repeats itself twice a second. So the time it takes for the signal to complete 1 full revolution is half a second. So if we just zoom in on the signal, and we can do that by alternating the time scale using this button. And we can also zoom in or zoom back on the actual signal itself by alternating the amplitude of the voltage on the y-axis. So we can alter the amplitude by using this button, and we can alter the time scale by using this button. So if we just line up the signal, so we can see here each one of these boxes along the x-axis corresponds to 200 milliseconds. So 1 second corresponds with 5 boxes, so we've got 1, 2, 3, 4, 5. So we can see that the time it takes this signal to repeat itself is from here to this point. Okay? And we can see that that is 2.5. Actually, sorry, as I was saying, the time it's going to take for the signal to repeat 1 full repetition is 1 divided by the frequency. And the frequency is 2 Hz. So in 1 second, or 5 boxes, because it's 5 times 200 milliseconds, 1, 2, 3, 4, 5, we can see that the signal repeats itself once and twice. So the time it takes to complete 1 full revolution, which is from this point to this point, is 2.5 times 200 milliseconds, or 500 milliseconds. Alright? So we can measure AC and DC signals. So we're measuring on channel 1 here, which is the yellow. We can also input another signal here because it's a 2-channel oscilloscope. Okay? We're only interested in measuring 1 signal at the moment, so we'll turn channel 2 off. So it's important to make sure when we're measuring a signal is to make sure, in this case, we're measuring an AC signal. We can also measure DC signals, as we can see here. So we have the channel 1 set to AC. But we can also measure an AC signal when we have the oscilloscope channel 1 set to DC. But it's important, if we're measuring a DC signal, it will only measure DC when the channel is set to DC.